We want to convert the polar equation to rectangular form. So right now, the polar is given by r and theta. Rectangular, we want to go to x and y. Okay. So for most of these problems, we want to use the fact that x is equal to r cosine theta and y is equal to r sine theta. So sometimes you'll see cosine theta is by itself. There's no r in front of it. And same thing with sine theta. So our goal is to put an r in front by either multiplying or dividing. So let's see how that works. Let's look at number 12. Do we see how sine theta is just sine theta? I mean, the 4 doesn't really do anything. So I want to have an r in front of the sine theta, because if I have r sine theta, I can replace that with y. So how do I introduce an r for sine theta by not changing the whole equation? So the way to do that is to multiply both sides by r. R times r will give me r squared, and then I'll have 4r sine theta. This is perfect, because r squared is x squared plus y squared, and then r sine theta is just 4y. So at this step, you can leave it as it is, or we can bring the 4y to the left and just say, well, this is the same thing as x squared plus y squared minus 4y is equal to 0. So, yeah, actually it's better to set equal to 0 for these problems. Okay, let's go on to number 13. This one looks confusing because it does not depend on r. So I don't care what r is. So we're given theta is 2 pi over 3, which happens to be over here. So this is r comma 2 pi over 3. I don't care what r is. So here, if r is 0, it's over here. So this is like 0 comma 2 pi over 3. If I pick r to be -1, it'll be somewhere here. If I pick r to be 100 or whatever, it'll be out here. So basically, you would just draw a straight line, and the only difference would be how far you go. But it's always going to be on that same line. Okay. For 14, I'm going to change secant theta as 1 over cosine. So I want to throw in a r in front of the cosine. So how do I do that? I have to divide it by r. Right? R would have to be in the denominator. So I have to multiply by 1 over r. And whatever I do on one side, I do to the other. Okay, so 1 over r times r would just give me 1. I have -3 over r cosine theta. Well, r cosine theta is just x, so that's 1 equals -3 over x. I'm going to flip both sides to get 1 is equal to, or actually I'm going to multiply by x, both sides, and get x is equal to -3. Okay, that's 14. For 15, we notice that there's nothing in front of the cosine. I want there to be r. So I'm going to multiply both sides by r. So I have r cubed is equal to r cosine theta. And I'm going to rewrite r cubed as r times r squared. Actually, that's what I should have done from the beginning. And then r cosine theta is just x. Okay, now r squared is x squared plus y squared. R is just the square root of that. And this is equal to x. So the square root of x squared plus y squared times x squared plus y squared would just be x squared plus y squared raised to the 3/2 power. And that is going to equal x. Next, I'm going to raise both sides to the 2/3 power. So the 3/2 and 2/3 will cancel, and I'm left with x squared plus y squared equals x to 2/3. So I'm going to bring the x to 2/3 over and have x squared plus y squared minus x to 2/3 is equal to 0. So this is the answer to 15. And last one, for number 16, we're given r equals 3 cosine 2 theta. So I'm going to put this up here. We know that cosine 2 theta is cosine squared minus sine squared. So this will be r is equal to 3 cosine squared minus 3 sine squared. So this time I have cosine squared and sine squared. When I had cosine and sine, I just wanted r in front to make the substitution. But because I have cosine squared and sine squared, I want to have r squared. So I'm going to multiply both sides by r squared. And we can think of r cubed as r times r squared. And then r squared cosine squared will be x squared. R squared sine squared will be, that will be y squared. Okay, so if r squared is x squared plus y squared, r is the square root of that. So I can combine this as x squared plus y squared raised to the 3/2 power is equal to 3x squared minus 3y squared. I'm going to raise both sides to the second power. And the reason I'm going to do this is because I want to get rid of the 2 over here. Because that is the square root. So when I raise it to the second power, this is going to cancel. So that gives me x squared plus y squared cubed. And then on the right, I can pull out a 3. I have 3 times x squared minus y squared. And this is all squared. So it's x squared plus y squared all cubed equals 9. So 3 squared is 9. And then I have to square the x squared minus y squared. So this is, we'll just leave it as this, as the final form.